Find the area of the hexagon. Go ahead and keep your answer exact, so it should be in root 3 form. So to find the area of a hexagon, you need to, well, we are going to assume it's regular. Sorry about that if I didn't say that. We need to find a side length. So to find a side length, we need to find the distance from here to here. We're in luck, because when one of your set of coordinates match, like our y's match, then we don't have to do distance formula. We get to do segment distance. So I need to find the distance between -2 and 6, not the whole coordinate. So if I start at -2 and I walk over to 6, I've traveled 8 units. From -2 to 0 is 2. From 0 to 6 is 6. 2 plus 6. Another way you can get that is you can always subtract to get distance. You can always subtract to get distance. All right, now we're doing our usual thing. 4 root 3, and technically that's 8. So we've got our apothem. We've got our perimeter, and divide by 2. Apothem times perimeter divided by 2. The final answer is 96 root 3. We don't have any units. We can put square units. Any questions about that? Tony and Edwin each built a rectangular garden. Tony's garden is twice as long and 3 times as wide as Edwin's garden. If the area of Edwin's garden is 30 square feet, what is the area of Tony's? There's a really easy way to do this. It's called non-proportional dimension change, which sounds kind of scary, but all you have to do is look at the formulas. So the area of one of the gardens is length times width, because we were told it was a rectangle. The area of the other garden is twice as long. So instead of L, you put 2L, and it's 3 times as wide. So instead of W, you put 3W. The area of the other garden is 6LW equals. So one of the gardens is length times width. One of them is 6 length times width. So the area of the other garden is 6 times more. 2 times 3. Yeah. So you take the area of Edwin's garden, you multiply it times 6, and then you have the area of Tony's garden. It's called non-proportional dimension change. So it's not the 1D, 2D, 3D thing. It's, oh, let me manipulate the formula and find out what happened to the area using the area formula. How many ways can you arrange 6 different cars in the front row of a car dealership? So how many ways can you, this word is important, arrange. So the order matters. They call it a permutation. But this one, you don't need to use the permutation function on your calculator. You can simply do 6 factorial. I told y'all in the review you could do this too. 6 permutation to 6, I guess. Or you can just kind of do common sense and think about how many choices. Okay, now I used one. How many choices do I have? Now I used one. And you can pretty much play out 6 factorial doing it the common sense way in your head. This, of course, is a triangle that's not special. It's not 30, 60, 90. It's not 45, 45, 90. So we need to use trigonometry. We've got opposite and hypotenuse. So our formula chart says to pick sine. Please use your formula chart on the TEKS test. It has the proportions on there. It has it. Careful, yes, make sure you're in degree mode. I can write in cursive. Okay, where is the variable? Denominator divide. Denominator divide. So 7 divided by sine 12. You get 33.67 or whatever you want to round to. Which is larger, the LA of the cylinder or the SA of the cone? The lateral area of the cylinder or the total surface area of the cone? All right, so LA of a cylinder is 2 pi r h. So we've got 2 times pi times 3 times 7. So what was the LA of the cylinder? 42 pi. Total surface area of the cone, pi r L plus pi r squared. So that will be 30 pi plus 9 pi. You're allowed to add these because they're like terms, but it doesn't quite compare. They were really close, weren't they? But the cylinder wins. Aw, thanks. Describe two transformations that would transform ABCD to LMNO. There are a couple of ways to do this. On the exam, you're going to need to be specific, although it will be multiple choice, of course. You could go ahead and reflect over the x. But if you notice, that will land you, this is 2 away, so 2 away would land you here. So if you land here, then you would need to translate down 1. Of course, you could reverse those. Like some people did, you could translate up 1, then reflect over the x-axis. But I'm pretty sure it needed to be a translation and a reflection. You could reflect it over the line y equals -1 and then move it. There were a couple of things you could do, but most of them were reflection and translation. In a math game, David was given the following clues and was told to guess which quadrilateral each clue is describing. I'll get to y'all's answers in a minute. 2 pairs of angles are congruent, 2 pairs of angles are supplementary, 1 pair of sides are parallel. I kind of wanted to release the clues one at a time, but anyways, 2 pairs of angles are congruent. That is all of them, right? No, 2 pairs, I'm sorry. That gets rid of kite, because it only has 1 pair of opposite angles congruent. So, this one, now we've narrowed it down to 3. 2 pairs of angles are supplementary. Well, that's all 3 of them, although rectangle and parallelogram have all consecutive angles supplementary. The isosceles trapezoid is the only one with exactly 2. But this technically is still all the ones left because it didn't say exactly. But when you get here, 1 pair of sides parallel. I guess it should have said exactly because we needed it to. But anyways, isosceles trapezoid is the only one with 1 pair of sides parallel. And it's the only one with 2 pairs of angles supplementary. For example, 80 and 80 and 100 and 100. So there's a pair and there's a pair. Whereas in a parallelogram, 80, 80, 100, 100, you've got a pair, and then a pair, and then a pair, and then a pair. So you have a lot more. Find the length of arc, e.g. the length, not the measure. The answer is not 30. Find the length of the arc. Okay, this is a proportion. It's arc length over, so the length of this over all the way around. Well, all the way around is called circumference. Equals m, the measure of this angle, over all the way around. And all the way around is 360. So, it's L over 24 pi equals 30 degrees over 360 degrees. This is where the angles go. That's where the degrees are. When you cross multiply, you get 2, and you need to attach the pi back on. Oh. So 2 pi inches, nope, not squared, 2 pi inches would be the length of the arc. Find the measure of the arc. So x is not a length this time. Find the degree measure of the arc. You do not have to solve it this way, but here's one way to look at it. I would find this angle, and then I would find this angle, and then I would find this arc. What's the measure of angle A? Good. You follow it. It's an inscribed angle. Inscribed angles are half their arc. So that angle is half of 80. It's 40. Triangle sum theorem. 40 plus 98. Subtract it from 180. I think you get 42. Oops, 2. 42 degrees. And then you can find the arc. If the angle is half the arc is double the angle. So you just take 42, you double it, and you get 84. Yes, you could have also found the linear pair to 98. Is that 82? And then add the arcs and divide by 2, and it equals your interior angle. So you could add the arcs and divide by 2, and that equals your angle, okay? So that form, if you hadn't memorized the formula, but you knew about inscribed angles, you could have done it the other way. 3 different problems, acute, obtuse, or right. Solve each one, please. So you compare c squared, you put that one first. You compare it to a squared plus b squared. You get a less than symbol. Less than means acute. It happens to you again here, I promise. And then you shouldn't have done any work on C. You shouldn't have touched your calculator because you should have seen that it was 4 root 3, 8. X root 3, 2x. So if it's 30, 60, 90, you hear that 90, you're like, oh, that's a right triangle. So acute, right. Find AB. So this one is stay on one segment at a time. Part times part equals, I'm going to call this X, part times part. And you get 5. But then you read the problem, and it says to find AB. AB would be 13. But you do need to know that formula, the part times part equals part times part, that the segments cut each other proportionally. Solve for X. We know that if we were going to be thorough and show all of our work, we know these would need to equal 90. So we know that X would be 30. We can place a 30 here. This is 2X, so we can place a 60 here. And now we realize it's a 30, 60, 90 triangle. We know this is X. This is our 2X. So this must be our X root 3. So Y would be X root 3. Last one. Oh, 2 more. The equation of a circle is x plus 3 squared plus y minus 5 squared equals 121. What is the diameter and what are the coordinates of the center? So we need to remember what these pieces mean. The equation is x minus h squared plus y minus k squared equals r squared. So r is the square root of 121. So r is 11, making the diameter 22. And be careful, this is not h and k, because it's minus, you take the opposite sign. So this would be -3, 5 would be the coordinates of the center of the circle.